Hi, this is Miss Litton, and this is our Honors Bio Unit 1 7th period review with these excellent students. Say hi. Fired up. Now, our ultimate goal is to know and understand and be able to apply science. But I know your short-term goal is I want an A, okay? And I would love for every single one of you to get an A. That is our goal. Do you like my shoes? That's how you're looking at them. Okay. So I would like all of you to get an A. That is something that you can be strategic about. You have to think how many hours are left in my day, right? So the test is going to be in how many hours? For some of you, 2, 3, 4, 5, 6, 7, 12, 13, 14, 15, between 17 and 18 hours, right? Before your test. You must sleep. Your brain is, listen, your brain is able to solve problems better if it sleeps. Your brain works better if you eat food. Not crap food, but good food, healthy food. Vegetables, some protein, okay? These are the things I want you to do. If you normally exercise, what do you think I want you to do this afternoon? Exercise. That's all good for you, okay? Listen to me. Your brain will not work well if you stay up till all hours of the night. And what happens is sometimes you just keep procrastinating and you keep pushing and you keep pushing and you keep pushing and then you're not done yet. You have work to do for other classes possibly. How many of you have homework you have to do for another class tomorrow? Okay. Oh my gosh, all your hands. Is it because it just got assigned or because you didn't take the time to get it done before the weekend was assigned?
Didn't take the time to do it over the weekend.
Now, let me tell you, any class you had, stop and listen and learn from this. If you have homework for a class tomorrow, it got assigned on Friday at the latest. Am I right?
Yeah.
Okay, so if you didn't do it all weekend and you knew tonight, not only were you going to have to study for your test, but any homework that was assigned to you on Friday, do you see how that was a poor choice? I'm not saying this to make you feel bad. I'm saying you could have planned for that. Tell the person next to you, did you plan well or plan poor? Go ahead. Look at me. You guys, I don't want to have to wait for you to get your head together. So, when you do your analysis, it doesn't matter if you planned well or planned poor. You have what you have now, am I right? So you have to move forward. One strategy would be this. Spend 20 minutes reviewing your honors bio. Maybe the first chapter, chapter 33, because it's the longest. By reviewing, I mean both input and what? Output. Then stop after 20 minutes and go do whatever that other homework is that you procrastinated over the weekend and didn't do. Do that homework for 20 minutes. But you know what I want you to do in between those 20 minutes? Take a break. Take your phone and set it aside for the whole 20 minutes you're studying chapter 33. Then before you do whatever homework you procrastinated on, then you can be on your phone or look at other things, go get a snack, and then go, okay, set a timer. You'd be surprised how much better you work, right? Remember the moment of silence we did for 9/11 today? Yeah. I'm assuming that was a minute. Was that a long minute? Yeah. It was, because you're like, I don't know what to do. I'm not a prayer. Or maybe you were a prayer and you prayed. Or maybe you just were thoughtful. I don't know. But when you have the clock on, you will be surprised. If you go, I have 20 minutes to do my math. I have 20 minutes to do my English. Do as much as you can in that 20 minutes, then stop. Take a break. Take 5 minutes. Get on your phone. Do whatever it is you want to do. Maybe it's time for dinner now or something like that. Then go 20 more minutes for biology. Then you're going to focus on chapter what? 34. If you then still have homework for other class, go and do it. Okay? That's how you want to, and give yourself time limitations. You will work more efficiently if you do that. You can say, I'm going to do 10 minutes of input studying on chapter 32, 10 minutes of output on chapter 32. Done. Now I'm moving on to my English homework. Okay? Go at it with a plan, and then tell yourself, I always want to set myself up. If you know you have an English test, don't have any science homework that night, right? Plan ahead. This is how a mature student acts. And that's the way I want you to go about it. Input and output. Let's talk about what to expect when you walk in the door. Okay? I'm going to say get out 5 sheets of paper. Why? Because I have 5 questions to ask you. Okay, on your written portion of your test, there will be 5 different questions, and as a team, you'll have about 32 minutes to answer those 5 questions. What's 5 times 5? 25. 25. Keep that, put a pin in it. Got it? When you're done with that group part, then you're going to do your multiple choice. I'm going to ask you 40 questions. Those are 2 points apiece. What's 2 times 40? 80. Did I do my math wrong? No. What's 80 plus 25? You have a chance at getting 105 points on your test tomorrow. Now, there's 2 ways you can look at this. You can look at this as cushion. Good grief, I can screw up for 5 points worth and it's still, I'm going to get 100%. Golden, okay? Or you can say, as some of you are like, I will get every one of those points, okay? And so you will get 105% on it. There's not a curve, there's not anything. I give you 105 points to earn of a 100-point window. Do the best you can on those 100 points. That make sense? Okay. Why? Because I love you. You know I do. Okay? Now, on the group part, okay, I will ask an additional objective question. So if you come in here as a team and you don't have those additional objectives covered, you will miss. Do you hear me? So you need to know. Now, you could delegate it, okay, but I call that abdicating the learning, okay? And I could say, you do chapter 32, you do 33, you do 34, I'll cover the labs. But what happens if I'm sick tomorrow? All of a sudden, the person who reviewed the labs is out. Do you see how that is not a wise choice? And that has happened before. Or let's say she was in charge of chapter 32, did an awesome job. She was 33, I was 34. I just didn't get to it or I forgot. Now, they in the group are going to suffer because of my laziness. Don't abdicate your learning. Everybody reviews all the additional objectives. Everybody reviews all the labs. But you can be a superstar in chapter 32, and you be a superstar in chapter 33. Do you hear what I'm saying? But don't go in cold not having reviewed that. Okay? Then I will just ask you objective questions off the calendar. I will ask you a lab question. I might ask you to do a diagram. What kind of diagrams? I don't know anything with a graph. Remember the 2 kinds of growth curves? What were they?
Exponential and logistics.
Right. Could you draw them? Could you tell me what organisms would be with either one?
Yes.
Could you tell me the survivorship curves?
Yes.
Type 1, type 2, type 3. You know what? Don't not draw it, right? Because if you're going to take a driver's test, you're going to practice driving first. Practice driving. Do practice driving before you drive because you might hit me. Practice drawing those out. Don't just go, I bet I could draw it. Get out a piece of paper and a pen and see if you can draw them. All of anything, any curve. Did we talk about population demographics? And do you remember the pyramid and the column? Do you remember that? Could you explain that? Could you draw that for me? Could you tell me who would fall underneath that category? If it was something I talked about, you want to be able to recreate that. That will be in the group part. Okay? The 80 points you're going to get on multiple choice, there are going to be 40 multiple choice questions. I'm going to ask you specifics. I could ask you a term. You've done your terms, right? You have your terms back. And when you're doing your input studying for chapter 33, the first one we ever talked about, I would read through the Go paper beginning to end. If I have an excellent study buddy, she and I are going to go back and forth if we have a chance to study together, or if we're FaceTiming each other and we're going to study together. Input, input, input. We're going to read the additional objectives. We're going to read the Go paper. We're going to read the summary at the end of the chapter. Then for our output, to get ready for our multiple choice, how are we going to get ready for that? Take the multiple choice question like a test, right? Like a test. 1, A, B, 2, B, whatever. And then grade it. Do all the odds first, and then you would do all the evens. Okay? Be scientific about it. Input, output, done. Then go input, output, done. So let's hit these key words just to make sure we're super cool about all these things. Ecology, what is ecology? Organisms and how they interact. Since this is the bulk of our unit, I would not miss that as a term, right? Any chapter titles, I would know all the terms of anything in any chapter title. Characteristics of population. Distribution, we did. S and J. What's another name for J? Exponential. Good. And when we look at those, What do they have in common? Yes. They both have lag, right? They both have lag. They both have what? Exponential. Good. Then what happens to change this one? Environmental resistance works against it. Where does it level off at? Carrying capacity. Good. What type of survivorship curve do you see with this one usually? No, this is a logistic. Okay, and remember they all start here at 1,000, right? And type 1 is, oh, and I die when I'm old, right? Age. Okay, this right here is that type of curve. This one is usually what kind of curve? Type 3. Type 3, right? So this is type 3, this is type 1, and then something that falls in between that would be what? Type 2. Type 2, like a bird. Remember the title of this? This was survivorship curve. Survivorship curve. You remember that? Yeah. Okay. So now going back here, we did distribution, survivorship. Oh, did I do density? No, don't worry about that. I threw that out. Survivorship curves 1 through 3. Type of growth curves. We did this. Humans. When we talked about humans and we looked at demographics, how did we do that? Do you remember this? There were 3. Oops, let me do it. I want to do different colors here. Sorry. Okay. Would this be typical of an MDC or an LDC? LDC. What did LDC stand for? Good. What's the green?
It's
Repro. What's the red? Repro. What is blue? Good. All right. And we talked about demographic transition, and what were they trying to transition into? A column. And this is more typical of a what?
More developed country.
More developed country. Good. And what can help them get from here to here? Medicine. What else? Education, food, access to water, right? Are the types of things that transition them from an LDC into an MDC. Are we good?
Yes.
Okay. Next. Predator prey. What do predator and prey tend to do? Cycle, right? So one cycles like right behind the other. This will be good. Okay? One tends, maybe not that dramatic, right? And they're interdependent on each other. If I want to be, I don't want to get eaten. I want to have some prey defenses. What are some things that can protect me? Camouflage. What else? Mimicry. Ooh, tell me about the 2 kinds, what kind of things I can do for mimicry. Batesian and Mullerian. Which one is I'm a bee, you're a wasp, you're a hornet, people leave us alone. Mullerian, how do you remember that? Stinger, stinger. Batesian, I try to get you to take the bait. I'm a moth, but I look like a bee or something. Moth and a bee, that's not very good. Big eyes, okay, good. What else could help me defend myself? What? Fright, warning coloration. We talked about poisons. We talked about thorns and horns, right? Anything to protect yourself. How about entering a relationship with another organism? What's that called? Starts with an S. Symbiosis. Keep in mind, every relationship is going to be positive for one, right? And if it's positive, that's what? Mutualism. Can you give me an example of that? Crocodile bird cleaning. Acacia ants. Okay. Sea anemone and clownfish. Good.
Human and dog.
Sometimes. What's this one? Commensalism. What does that mean?
It means
Good for one and the other one doesn't care. What was your classic example for that? Do you remember? Epiphyte, it's a plant that grows on another plant. Okay, plus what? Minus, what's that? Parasite. What's an example of that?
Lice.
Lice, perfect. Okay. Symbiotic, disturbances in a community. What did we find out about disturbances? Moderate amount, bless you, of disturbances and moderate frequency as well. You don't want to have too much disturbance, but you don't want to have too little. You don't want to have too high frequency. It's the Goldilocks, just right. Okay, and that helps kind of clean house. That was chapter 33, done. Okay, chapter 34, producers, consumers, decomposers. What do consumers and decomposers have in common?
They both need to produce.
What?
They're autotrophs.
Consumers and decomposers
Heterotrophs.
that are both heterotrophs, right? Now, what if I eat only plants? What if I eat only meat? What if I'm biologically built to do both? Omnivores, good. What's another name for a producer? Good. What if I eat plants again? What am I?
Primary consumer.
Herbivore. Another name for it is primary consumer. What if I eat animals that eat plants? I'm a... There we go. Okay, you got that. Energy flows and chemicals cycle. Good. And we looked at how energy could flow through a food chain and a food web. What's the difference between a food chain and a food web? Food chain is just, this to this to this. A food web is all the interconnected feeding relationships, right? Okay. So on a test, if I say the squirrel ate the nuts, then the fox ate the squirrel, and then the wolf ate the fox, what would that be? Food chain. But if I bring anything else in there as well, the rabbit had the nuts and the fox ate the rabbit, then it's a food web. Good, okay. Trophic levels. How do I get trophic levels? What are trophic levels? That'd be a good group question. You stack up all the producers, and on top of the producers, you stack up the herbivores, right? And then you stack up yes. Remember, and we said when we looked at models about that, sometimes it had it as a straight up pyramid, but we know how much gets passed on each time. 10%. Maybe 10%, and then this would be your primary consumer or your herbivore, and then 10% from that would be your secondary consumer or carnivore. And then if I could do 10% of that, right? And that's why there's only 3 to 4 levels in our trophic levels. Yes?
How would you define trophic level?
Trophic level is each part of your food chain, I guess is what you could think of it. All right, next we did that. Okay, now it's time to do our cycles. Water cycle, super easy. What is this? What's this? And then when a liquid becomes, oh yeah, I said it wrong, but you're right. When a gas becomes a liquid, it's going to condense, right? Underground water tables, aquifers. How can man screw up the water cycle? Pollution, right? What else did you say? Groundwater mining. You can end up creating what? Sinkholes. Good. Phosphorus cycle. Where does the phosphorus start? Rocks. How does it normally get out of the rocks? Erosion. Just normal process, right? Phosphorus is a limiting factor, so it keeps growth in check because autotrophs need it. So then we can talk about when autotrophs, herbivores can eat autotrophs, and that's how it cycles through living things. But if man screws it up, what do we tend to do? add in fertilizers, increase the amount of phosphorus, which then all of a sudden, who can we get a whole bunch of?
Algae.
Algae, we get an algae bloom, which you think, yay, because those are what?
Die.
What are they? Why would we think yay?
Because algae plants.
Algae's plants, plants are producers. And you would initially think yay, but what are all those plants going to do? Die. And then when they die, don't skip the steps. When they die, then who works on them? Decomposers work on them. When the decomposers, they're the ones who suck all the what? Oxygen out of the water. Yeah, then die. Okay, nitrogen cycle. Let's do it right now. Here we go. Ready? Where does nitrogen start out? Here we go. Where is this whole song? Instagram and YouTube. Here we go. Nitrogen fixation takes nitrogen gas and makes it into ammonia. Good. Who does it? Nitrogen fixing bacteria. Step 2. Nitrification. First nitrite, more nitrification, then nitrate. And those are nitrifying bacteria that are doing that. Okay? Nitrate. Who can use the nitrate? Plants. And then animals can eat the plants. Then, if the plants and the animals die, who works on them? Decomposers. And it goes back into what? Not to nitrogen fixation. What is this? Ammonium. And then you can do nitrite, nitrate. What's another way to get nitrate? What's that? Atmospheric fixation. Now, I can put it back up through denitrification back into the air. Do you think you should know those? Yes. Is it a possibility I will ask you to diagram one of these cycles and tell you how man messes it up? Yes. Okay. And how could man mess that up? Acid rain, pollution. Good. Carbon cycle. CO2 or carbon can be in living things. It can also be in our atmosphere. Okay? And what removes carbon dioxide from the atmosphere? Photosynthesis. That's carbon fixation, right? Nitrogen fixation removes nitrogen out and gets it into a form that plants eventually can use. Carbon fixation is removing CO2 from the air. Who does that? Plants, right? That's the only thing that will take it out of the air. Photosynthesis by plants. What kind of things will put CO2 into the air? Respiration. Looking for another word. Respiration. Combustion, burning of things, right? Those will return, decomposers, return CO2 to the air. Now, what would be a problem with having too much CO2 in the air? It acts as a and like a shield. The heat can get in, but it can't get out. Bounce back, hot. Ooh, glaciers melt, changing global weather patterns, death, destruction. Okay, chapter 34, done. Okay, chapter 35. Why did I say nature versus nurture? Why would I say something like that? Nature versus nurture on our behavior. Nature would mean it's in our genes, our DNA. Nurture means it's in our environment, right? And so we talked about what were some of the experiments that says our behavior is in our DNA. What are some different experiments that we discussed? This is the chapter we just finished.
Like the crossbreeding?
Crossbreeding between what?
Like the birds.
Lovebirds, snakes. What else in our DNA? What? Twin studies. What else? Slug, the aplysia. Remember, it laid eggs even though it had mated. Remember, 1 million eggs. Whip it around, right? Those were all genetic studies saying it's in our DNA. Now, if it can be by our environment, then that's an example. That would be like learning, right? Something new. We're learning something. It's not something we were born with. We learned it. And we talked about we could learn at a specific time. That is called what? Imprinting. There's a sensitive period. Like when birds learn their song. Or salmon know where their home stream is. Or who's the mom. Remember we talked about the man Lorenz and he looked at them when they were hatching? That's imprinting, a sensitive period. Associative learning. What do you hear in associative? Associate. So, no. Associate. So it's one thing with another. We looked at a 2 classic groups of experiments. Do you remember what those were? Pavlov's dogs, which was called what? Classical conditioning. And that was something that is a response that you would give to like a treat or a sound or a bell. Okay? What was the other kind of conditioning? Operant. That means perform your operation and then I will give you this. One comes before, one comes after. Skinner used what? Rats. Skinner rat. Are you thinking Skinner rat? Ooh, do you want a rat suit? No. Skinner rat. Okay.
Skin the rats.
Skin the rats. Okay. We talked, wait, I'm missing another one in cognitive learning. Do you remember some of the other ones that we talked about? Insight. Remember the crow, right? And how he would go and the crow could pull up the string and step on it, and so he brings the meat up. And then I make spaghetti like my mom makes spaghetti. What would that be? Imitation. Good.
The monkey, how he washes the sweet potatoes.
Wash the sweet potatoes. Good. Okay. Then we started talking about specifically mating behavior. And when we talked about females choosing, you could break it all down into two reasons why they were, what their choice. It's not like they're here, but like, why would you choose? One hypothesis says what? Why would you choose? For looks. What did we call that one? Runaway. They're running away with those looks. That would be like looking at the different peacocks and who had the prettiest feathers. For looks, runaway hypothesis. What's your other hypothesis? Good genes. They can provide. They're stronger. They're faster. That's what's important. Okay, that's why females would choose. And we talked about on territory, who usually establishes a territory? Males establish a territory. So usually when males have a territory, they're getting a whole group, guys, they're having a whole group of females together that they're taking over in that territory. And due to territories, you can have what between males? Competition and fighting. Sometimes it could be a fight that's bloody, sometimes not, because you don't want to bloody yourself up so much by the fight that you end up not being able to finish the job, so to say. We talked about differences between males and females, sexual what? Dimorphism, where the males and females look different. And you're going to especially find that when it's the runaway hypothesis, but you could also find that as well with the good gene hypothesis. When the female's choosing, usually see big differences between males and females. Okay, then we went into sociobiology. We're almost done, and the bell's going to ring. Altruism. Does altruism actually probably exist? No, not really. It's some modification of it, because altruism is saying, I'm giving up myself and my chance at reproductive success. What is that called? Reproductive success. Measurement of it. My fitness. I'm giving up my fitness for someone else for no reason at all. And really what we found is they gave it up because they were giving up their fitness because really they were protecting their fitness by protecting their what? Offspring or their family or relatives in kin selection. Or I am expecting something in return. I'm not truly giving you this favor just out in the open. I'm expecting some repayment. What was that called? Reciprocal altruism. I'll give you a blood meal that I got because I know that you're going to give me a blood meal. Yeah, reciprocal altruism. Okay, then we talked about communication. Of all these communications, which ones are the fastest ones? Auditory and probably visual, right? Probably auditory and visual, because tactile, I have to be what you?
Close.
Yeah, I have to be near you, right? Okay. Which ones work in the day or night? Auditory, tactile, chemical. Yeah, visual will work in the night if it's like a flash of light or something. Okay? A mating call could be an auditory signal. Barking, a warning, could be an auditory signal. Visual, you could think of fireflies baring your teeth, flapping, doing a dance of some sort that attracts a mate, maybe. Tactile, what was the classic one for tactile? be dance because you have to touch the dancer. Okay, or you could do grooming. And then chemical would be leaving some sort of scent, some sort of usual sexual scent. What is that called? Starts with a P. Pheromones. Okay, we did it. Additional objectives, all the chapters. Go to bed early. Have a good meal. Plan out your evening. Don't procrastinate. Okay. I love you very much. Be smart.
We love you too.
Thank you.